Bunnies and Chicks. Our bunnies like to eat carrots and our chicks like to eat corn, but unfortunately they have ended up with the wrong food. So we need to help them swap places to reach their correct food. To get to the correct food, they can sidestep onto an empty tree stump or leapfrog over one occupied stump to reach the next empty one. The question is, what is the least number of moves possible for the chicks and the bunnies to swap places? This is best done practically, so you could use coloured counters and draw out a set of tree stumps to help you explore this investigation, or click on the link below to print out one or more of our versions, depending on how far you would like to explore this investigation. And as you work, try to think of a way to record how you explore this investigation, any light bulb moments, or times when you felt stuck. You may also find talking it through with a friend is helpful. Pause the video while you have a go at finding out the least number of moves possible for the chicks and the bunnies to swap places. How did you do? And what was the least number of moves you found? After a few attempts, we found that if there are 3 bunnies and 3 chicks, then the least number of moves possible for them to swap places is, well, why don't you count along with us to find out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 moves, which we decided to record like this, where S means a sidestep and J means a jump over. We can develop this investigation by changing the number of bunnies and chicks to identify and confirm any patterns in our recordings. A good way to do this is to start with 1 chick and 1 bunny. Pause the video while you have a go at finding the least number of moves. We discovered that the least number of moves is 1, 2, 3. Likewise, we can repeat the investigation with 2 chicks and 2 bunnies. Pause the video while you work out how many moves there are this time. How did you do? We discovered the least number of moves possible was 8. We can test out our light bulb moment with 4 chicks and 4 bunnies, where The least number of possible moves should then be 1, add 2, add 3, add 4, add 4, add 4, add 3, add 2, add 1, which would be 24. Pause the video while you check this out. Did it work? Was the least number of moves 24? Let's have a look. So we've identified a pattern to follow for working out the least number of moves, which we could identify using our Cuisenaire rods like this. In this way, we can identify patterns in each step of the sequence we have created, which can be written as calculations like this. Firstly, there's a group of 3 blocks in the centre of each step of our sequence, which can be used to create the first part of any calculation. So, if 3 blocks of 1 equals 3 times 1, then what will 3 blocks of 2 equal? Pause the video while you make a note of any ideas. 3 blocks of 2 equal 3 times 2. 3 blocks of 3 equals 3 times 3. And 3 blocks of 4 equals 3 times 4. But what about the remaining blocks? Can we rearrange these to identify any further patterns? Well, in the second step of our sequence we have 2 blocks of 1, or 2 times 1. How could we rearrange the blocks in steps 3 and 4? One way could be to make 3 blocks of 2, or 3 times 2, and 4 blocks of 3, or 4 times 3. But what calculation could we write in step 1 of the sequence which follows the same pattern? To follow the same pattern, the calculation would need to be 1 times 0. Finally, for each step of our sequence, if we work out each calculation and then add the 2 answers together, we find that we have found a way to calculate the number of moves for each step, which, if we look more closely, we can use to make a general statement that is true for any number of chicks and bunnies, where we can use n to represent the number of chicks and bunnies and n minus 1 for 1 less than the number of chicks and bunnies. Which, as a general statement, we can write like this: n multiplied by n minus 1 add 3n equals the least number of moves. But that's not all. If we multiply out the brackets, then we discover that n multiplied by n is the same as n squared, minus n multiplied by 1, which equals n. And of course, we mustn't forget to add the 3n. We can then simplify this statement even more, because subtracting an n and then adding 3n is the same as just adding 2n. So now our general statement in its simplest form is n squared add 2n to find the least number of moves required, no matter how many bunnies and chicks we have. We hope you enjoyed this challenge, but there's even more to it than we mentioned here. So if you want to investigate further, then why not check out our Bunnies and Chicks bonus video, to discover even more. Bye for now.